everyone. Sorry for the delay. We had some technical difficulties to get the slides showing on the screen. My name is Xing. I work for Huawei on OpenSDS. I'm also a contributor in Kubernetes and CSI. Before joining Huawei, I also worked at the Dell EMC. So today we are going to give an intro on the CNCF Storage Working Group. We want to thank Alex, who prepared the slides for us. 大家早上好，我叫杨欣，我在华为工作，我也是 K8 社区还有 CSI 社区的贡献者。今天呢，我们会讲这个 CNCF 存储Working Group， 要给一个介绍。Here's my co-presenter, Quinton.
Thank you, Xing. Can everyone hear me? Can you hear me? Yes, thank you very much. We will be giving a little introduction to the working group today. I'm Quinton. I think I know some of you personally. I'm on the CNCF Technical Oversight Committee, that's so-called TOC, and that's how I got involved in the storage working group. And what we're going to do today is just give you an idea of who we are, what we doing with ourselves, give you a chance to figure out how to get involved if you're interested, and then we'll give you a little bit of a taste. We've been working on a white paper to sort of try and clarify the whole storage landscape around cloud native computing. So we'll start with that, but the deep dive session, I believe, is tomorrow. We'll be going into a lot more detail on the content of that white paper, and in both sessions, we welcome collaboration, so please feel free to interrupt us with questions if you would like. There will be a section at the end as well, but we have quite a lot of time, so I'm personally happy to be interrupted if somebody wants to. And yeah, treat this as an interactive session rather than as me teaching you a bunch of things. All right, with no further ado, Johnny, give me that. So this is us. These are just contact details. This is where we live on the internet. There are a bunch of meeting minutes if you want to see what's been going on in the past. There's a mailing list, and there's obviously the ubiquitous GitHub repository with some information in it. Although both Xing and I currently work at Huawei, I want to make it very clear this is not a Huawei-only effort. You can see a very long list of names of companies at the bottom of the slide there. All of these have been involved at various points in time with the storage working group. The white paper itself has got many authors from many different companies. So I want to make that very clear. This is a collaborative effort across all storage products and anyone with an interest in storage across the CNCF. So, some of the obvious questions. Why is storage critical, and particularly in cloud native computing, why is it critical? There's a lot of noise about stateless applications and how wonderful they are, and they scale horizontally and all of these good things. But the reality is that many applications do actually have some state. In fact, it's very difficult to find ones that are truly don't have any state. They do exist, but there are not a lot of them, and many of them rely on some kind of storage, be it locally or distributed or remotely, whatever the case may be. So getting a clear understanding of what the options are that are available to you and how to use them and what the pros and cons of the different approaches are is very important. And then, in many cases, you want interoperability between these solutions. So you might start with a simple option, which is, easy to understand, easy to deploy, and get up to a certain scale. And then maybe you want to be able to, switch up to something a little bit more scalable later on in the life cycle of your project. And you don't want to have to redevelop your whole application and figure out, difficult problems at that point. So this is one of those, fairly obvious statements, but it's in everyone's interests to enable a storage ecosystem that is vendor and platform neutral and provides interoperability for applications. So what do we kind of see as our mandate? So working groups in the CNCF world are kind of limited time things. We usually set out a problem statement. We go about trying to address whatever that thing is. Once that's done, we either shut the working group down, because we don't want these working groups sitting around having meetings for the sake of having meetings, or we decide that there's another problem worth solving that involves, similar people and a similar space, and then we, explicitly charter the next stage. So this is basically our first set of priorities. We want to clarify the terminology in use. So there's lots of words being bandied about, consistency, availability, scalability, all of these things. And some of them don't have very precise meanings, and it becomes very difficult to have meaningful conversations about alternative technologies, pros and cons, etc., if you don't even have a common vocabulary to use to discuss these things. So that's one of the things we want to be very clear on, is make sure that we have a common language that everyone can talk about the same things and mean the same things with those words. We also want to understand the primary attributes of storage, and some of these attributes apply to things other than storage, but we focused on the stuff that's really important to storage. I'm not going to go through those right now, but we have a slide a little later on where we can talk about why is availability of storage important, what does it look like, what are the different options. Durability, I think that term is reasonably well understood to mean that if you save something, it doesn't disappear later. Performance, there are different axes for performance. There's throughput, there's IOPS, there's many different kinds of performance. Scalability, same thing. Does this thing scale by number of IOPS you give it, amount of data that you give it, etc. And consistency is one of those very misunderstood terms which can mean very different things to different people. And turns out to be a pretty big deal. And I'm sure that more than one person in the audience has, adopted some particular storage approach technology, only to find that that little thing called consistency at the end actually makes your application enormously difficult to write, enormously difficult to run, and leads to a whole variety of problems that you didn't plan to have, but in essence came out of the storage choice that you made. Sometimes early on in the project. So we want to help people to, some of these less consistent storage solutions are totally appropriate for certain applications, and they make a lot of sense, but if you choose them for the wrong application, they can cause enormous amounts of pain if you're not careful. Right, and with no further ado, I'm going to hand over to Xing to continue with the presentation, give you a little bit more background on some of the CNCF storage projects. Want to take that?
So over the last year, there are several projects presented at the Storage Working Group and got some feedback. So here are the list of the projects. And among them, there are a few got accepted by CNCF TOC. So Rook, that's a storage orchestrator for Kubernetes. That was the first storage project got accepted by CNCF. It was first accepted as a sandbox level project. Now it has become an incubation project. And also Minion, that's another project presented at the working group. That is on the distributed object store. That is not supported by Rook. And Vitis is a project on how to scale horizontally the MySQL cluster. That was accepted as the second CNCF storage project. It's accepted at the incubation level. And we also have a T-Kiwi. That's a project on key value stores. That was the third project accepted by CNCF as the storage project. It's accepted at the sandbox level. So Quinton, maybe you can explain to us, so at the POC level, how do you decide whether a project should be at incubation or sandbox level or graduation?
That's a very good question, and one that comes up quite often, not only in the context of storage, but in general in CNCF projects. And I think we've perhaps, as an organization, not done a very good job of clearly communicating the difference between these, so I'd like to take the opportunity to do that now. The basic model is that, at the end of the day, a lot of people want production-ready, projects with multiple companies supporting them. So if any one of those companies changes strategy or decides not to, continue pursuing that project, the project doesn't die. It's got contributors from different companies. It's used in production widely by lots of people. And, people can the Americans have this great saying, they can bet the farm on something. So, if you inherited this farm from your grandparents and you promise somebody you're going to do something, and if you don't do it, you're going to give them the farm, that's a big deal in America. So the graduated project is our way of saying you can bet the farm on that. You can rely on this stuff into the future. It's not going to go away. It's well supported. It's got a lot of developers. And there's a whole bunch of detail which you can find out on the CNCF website about exactly how we ensure that, but the principle is that those are solid. Right now we have Kubernetes, we have Prometheus, I think Envoy today, I think half an hour ago, became a graduated project. And there are many more in the pipeline. There'll be news coming out in the coming months. Certainly, if some of you might be in Seattle KubeCon in a month's time, there'll be more announcements forthcoming in that space. So then the question is, what happens before that? So, projects don't miraculously, you don't develop a project and suddenly it's, production ready and has 100 users and, 15 companies contributing to it. How do you get there? The reality is you need some kind of incubation stage where projects can get to that level of maturity. And when the CNCF started, we actually had 0 graduated projects. So even Kubernetes and Prometheus were not considered graduated. They were, used widely in production. They had multiple users, but we didn't think they were solid enough to bet the farm on. So we called them Incubation, and we left them for a couple of years, it turns out. Kubernetes, I forget the exact date, but I think it graduated around about a year ago, and Prometheus more recently than that. So, that gives you an indication of the differences in the level of maturity. However, for incubating projects, we do want a couple of, we want people to be able to use these in production. And in fact, we usually require evidence that they are being used in production by at least a few companies, maybe not everybody. And we also want to have, very healthy developer activity happening there. So multiple committers, multiple maintainers, if you report a bug, you want to know that it's going to get fixed. All these kinds of things. So that's incubation. Not quite graduated yet, but it's a solid project that you can start using in production. Maybe not bet, the whole farm on, but at least bet a little piece of your farm on that. That's great, but we found out over time, this we kind of discovered through experience over time, that there are a lot of projects which are not even at the incubation stage yet. Some of them are actually just ideas. So, a group of developers have this idea, and they need a neutral home where they can actually write code, commit code, and it's clear who owns the code. It has a support infrastructure around it, things like continuous integration, CI/CD systems. It has a decent, code of conduct, and there are ways that you can get code into that thing, and everything's kind of organized, but it's not intended to be ready for production just yet. And there's obviously a range of projects in that space. There's the idea that has no code, and there are just 2 or 3 companies that want a place to go and collaborate and figure that thing out, all the way up to something that is not really production ready yet. Nobody is actually using it in production, but it's a real project. It's got code, it's got people, there's stuff that works, you can actually go and run it. So there's a fair range there. So those labels that we used earlier, right at the bottom, sandbox. Next step up from there, incubation, and next step up from there, graduation. Hopefully that clarifies that. Does anyone have any questions? Because this is a pretty highly questioned area. Oh yes, 2 hands.
Sorry, just, there's a bunch of projects here, but only Root Business and TKB was accepted even as a CNCF project. So what's your standard to say exactly which project should be even as a sandbox project for the CNCF?
Okay, that's a good question. So sandbox, the limitations, the barrier to entry is intentionally very low. The project needs to adhere to it can't be some random thing that has nothing to do with cloud native deployments or the cloud native way of doing things. So as long as it's aligned with the CNCF's basic principles, as long as it has the right licensing, so it needs to fit into the legal framework that is provided by the Linux Foundation and the CNCF. And we need to, ideally we would like it if it's something that we would like to see go to incubation and graduation to fill out the CNCF, the full CNCF stack and architecture, it'll get in. If it's something we don't really care about and we don't, falls down on any of those particular areas, then it might not get in. But the barriers to entry, let me make it very clear. Incubation, very easy to get into. You don't get a lot of endorsement. We don't tell anyone that your product is ready for production or that they should go and use it or put it up on slides for the most part. Or there's no advertising that goes around it. It's just a neutral home for you to collaborate in. The fun really starts when you get to incubation level.
Yeah, so just a follow-up a bit. So can you give some example that, because there's a bunch of projects here, and give some examples, say one of them probably got being rejected by the CNCF due to some reason. Maybe more like more detail rather than just abstract the detail of it.
Sure. I think that's probably a question better dealt with in the conversations afterwards, if you don't mind, because there's too many of them and there's a lot of detail there. Another way of thinking, so getting rejected into the sandboxes is relatively unusual, and I can't even think of too many projects that have been rejected for non-obvious reasons. Obviously, if there's no open source license, sorry, can't help you, or if this thing is a kernel for Arduino devices, it's not really, obviously cloud native in nature. But other than that, it's reasonably open to everyone. There was another hand over there, I think. Okay, so the question was, for those of you who didn't hear, what are the levels of involvement for all of these projects? And with that, I'll throw Ying in the deep end and ask her to answer that question. Xing.
So CSI is actually not really a project under CNCF yet, so maybe there will be consideration in the future. But right now it does have 4 COs participating, right? We have Kubernetes, Mesos, Docker, and Cloud Foundry. And it's going to go GA very soon. So we'll see whether it's going to be a CNCF project or not. Rook, we talked about that. Rex3 currently is not. I think they was trying to get that into it, but right now I haven't heard anything to follow up. And then the .mesh Yugabyte, I don't think they are. I don't know if they applied for it. So basically for the CNCF Storage Working Group, usually we have some storage projects they want to get presented, but it does not mean that they will definitely want to apply for a project under CNCF. So an example would be actually OpenSDS, that's a project that I'm working on. It's already a project under Linux Foundation. So we presented at this working group because we also have solutions for cloud native, but it's not a project under CNCF. Minion, I mentioned earlier, that's right now supported by Rook. An open service broker that already has an integration with Kubernetes. Vitis is a project in CNCF, and OpenEBS, I think it's not. It is definitely not a project under CNCF. I don't know if they have considered that. So I hope that answered your question. Okay. So Clinton mentioned earlier that we worked on this storage working group storage landscape white paper. So we have got a draft. So here are the outlines. In this white paper, we talked about the attributes of a storage system. So like availability, scalability, performance, durability, and consistency. And we'd also look at different layers of a storage solution and look at how that could impact those attributes. And we look at the data access interface. So the workloads will consume storage through those data access interfaces. We have 2 categories of this interface. One is volumes, the other one is application APIs. And volumes actually include both block and file system interfaces. And application APIs include object stores, key value stores, and databases. And we also look at the orchestration and management interfaces. So we focused on the volume interfaces supported by the container orchestration systems like CSI and also Kubernetes Flex Volume, Inti drivers, Docker volume driver interfaces. So here are the authors of the white paper. Of course, we have many more contributors provided feedback to the white paper. Here are the next steps. So Quinton and I have another session tomorrow to give a deep dive to present the findings on this white paper. And we want to find out what are missing from this white paper, what else we should be covered here. And we plan to finish this paper by KubeCon Seattle, which is 1 month from now. And also, we'd like to do some case studies and see how storage is used in the real world and publish those case studies. So I think that will be really, really interesting. And also, most importantly, we want to get some feedback from the audience, you, and to see what you want to see from this working group. What do you want us to work on? So here are some other storage sessions at KubeCon. So Xing and I have a session this afternoon. We will talk about the snapshot feature we implemented in Kubernetes and CSI. And then, as I mentioned earlier, Quinton and I have a deep dive session tomorrow. And then there's also a case study on Vitis. And also there are 2 sessions, one intro and one deep level session on Rook. And I think Jared is sitting at the front row. He will be giving those talks. So with that, are there any questions? Oh, yes.
The cluster is so huge. So we have one problem. Because we use lots of storage cluster. In Kubernetes, there are no storage schedule, such as we create a PV, but we want to check which cluster is located. So in Kubernetes, there's no about the storage schedule. And this question, do you have some suggestion?
Ying, do you want to take that? Xing?
Yeah, sure. Yeah, go ahead.
No, so do you want to take?
Yeah, sure. So I think that area is still limited. I think there are some level of like the quota resource management in Kubernetes, but I think it's definitely not enough. I think this is an area that definitely need more work. So if you have any ideas, like if you know something that you guys work on, you want to contribute, that would be something very valuable.
I had a follow-up question to that, and I wasn't quite sure whether your question was, how do you intelligently schedule a workload into the correct cluster that has the right storage, or is it directed to specific nodes? So you want to put a pod on a particular node that has, an SSD or whatever. Which of the 2 questions were you asking? Was it scheduling into a particular cluster or scheduling onto a particular node? Okay, so it's per cluster. Do you want to hand the microphone?
Yeah.
If you want to ask your question in Chinese, that's totally fine. We have lots of translators.
we have lots of database. OK， 我大概说一下，就是我们有很多机房，然后有很多存储类型，然后网络架构也不同。其实说这里会因为存储就我们当前用其实是一个不可靠的状态，就经常会出现 I/O hung 类似这样的一些问题。所以说我们把存储拆了很小很小，这样的话会涉及很多个存储集群。那这种集群在我们不同的应用场景，它可能对存储的需求是不同的。所以说这块是有很多关于调度方面的一些问题。 就是当前我看到的社区关于存储用，仅仅是在于用说我对这个某个存储类型的是有支持的，但是没法就是管理多个存储这样的一个不同的存储，然后并在一起使用的那种场景。
Okay, yeah, so let's see if I can translate that. I think he's saying that they have a different storage, and then they may have different capacity, and then how to choose which one to use. Right now, it's mostly through we have like storage class, but those are different storage. Those are different types, but not necessarily have the capacity information, right? I think that's what you were trying to say. And then the scheduling part, I think that is an area actually I think it needs more work.
Yeah. I definitely understand the requirement, and I think it's fairly clear that you're not the only person who needs that. I haven't personally been involved in the details of that scheduling, so I'm not 100% sure, but I'm pretty sure we don't currently support what you want, and I think this is exactly the working group to bring that up in.
Yeah, I think the area is related to the topology work the SIG storage has been working on, right? So you can have different topology requirements and where you want to locate your workload, and scheduler can understand based on the topology. And this is the area I think we are working on. And the CSI start to support topology in the new release. So if you have some requirement we haven't covered, so we can talk about detail offline. Yeah.
Excellent. That's exactly what this session was for, is to have the audience answer questions from the audience.
Yeah. So I have a question. Currently now we are implementing the CSI, right? So we also have the flex volume driver and the.
Sorry, could you speak into the microphone?
We have a flex volume driver and a dynamic driver also, provisioner basically. So what is the provision for the people who already have these drivers implemented, and how the CSI will adapt all these things, or the vendors have to write their own drivers for the CSI if they already have a flex volume driver and dynamic provisioners? So.
Yeah, so you do need to write another CSI driver, because the flex volume driver, we are not going to add any new features to it. And I think recently there were some people asking questions on how do you migrate your, let's say you already have some volumes created by your old driver, how do you migrate, right? So I think that is something that we are just started discussing, but we don't really have a concrete plan how to do that yet. But there is a design on how to migrate the in-tree drivers to CSI, but that's not what you actually, because you use flex volume, right? Yeah.
I think there's another question at the back there. And then I'm afraid this will have to be the last question, because I think we're out of time.
Is this the last question?
Oh, maybe we can have some more.
Okay.
I have one question. Okay, we have
one
some more
question related to the storage QoS. I mean, if I want to, for example, we have some workload consume a lot of storage bandwidth, but this will affect the other performance of the application on the same host. So we want to limit the I/O bound related storage. So is there any proposal in the community?
Xing, do you want to take that? I can do a very high-level job of answering it. Maybe you have more detail than I do.
Yeah, so I think you can use the storage class to differentiate, but we don't have anything right now to limit the bandwidth. I don't know. Xing? Yeah, I don't think we have that right now. But so if you have some ideas, definitely you can propose those. Oh yeah, sure.
Yeah, I think there are, and I'm not involved in all the various Kubernetes SIGs in detail, but I understand there is a lot of work on the network quality of service and being able to partition like a shared network device on the node to make sure that individual containers don't use up all of the network bandwidth, for example. Now, if you're connecting to storage across your normal shared network, You could make use of that in combination with storage classes, etc., to achieve roughly what you're wanting to do. If you have fiber channel or other ways of doing it, I'm not sure how well that would work. So yeah, definitely a good topic for discussion in this group. I can imagine that being a big deal for a lot of people because, I was involved in the EBS development in the early days of Amazon, and one of the biggest problems was, when there are too many clients against the same EBS volume, or the machine hosted by the same EBS volume, or if you have too many clients on a machine and they're all trying to get across the network to storage, there's a lot of interaction there, and if you don't manage it properly, it can be pretty bad. We have a few more minutes, so we can field some more questions if there are.
Hi, I'm from Qing Cloud, and I am a CSI driver developer. And I have a question about what is CSI specification plan. Well, when we release CSI specific version 0.4.0 or CSI version 1.0, and when we will supporting Kubernetes CSI, such as we update our external provisioner and external snapshotter.
Yeah, actually this week we're planning to release 1.0 this week. So work is going on, so it's coming. CSI 1.0 is coming soon, hopefully this week. And you were asking about external provisioner, external snapshotter in CSI, sidecar containers, you're asking those? So that we already have, right? A new version, CSI version, it's coming actually this week, I think. Right now we are trying to cut 1.0, so there won't be a 0.4, so it's going to be 1.0. Yeah. Yeah, go from 0.3 to 1.0. It's coming this week. It should, yeah. So I think there was a few things that we want to get in before that. So hopefully by the end of this week, it will be cut. Which one? CSI? It's already supported, right? It's already.
Xing, could you just repeat the question so everyone can hear?
Oh yeah, I think the question is when CSI will be GA, right? And when that will be supported by Kubernetes. It's already supported, right? You haven't, okay. Yeah, but if you have other questions, you can ask me after this, yeah.
One last question. Any more hands?
Okay, I would like to ask a very basic question. Okay, currently I'm developing our CSI driver, but I think CS drivers, our CS driver is standalone, I mean out of the community. So I would like to join in more communication. Yeah. So I would like to, how can I get involved in the community, especially the storage part in the Kubernetes? Yeah, thank you.
Yeah, so for CSI, there is a Slack channel for CSI. Yeah, and also there's a SIG storage, and there's a Slack channel, and then there's also a CSI working group Slack channel. Yeah, so I can show you after this. Yeah, you can join that. And then there are also meetings. But maybe the time zone it's usually like 12 o'clock, 1 o'clock Eastern time is maybe too late for you. But there are recordings, so you can watch the recordings afterwards. Yeah, so there are, so we do have, so SIG Storage has bi-weekly meetings, and then CSI community also has bi-weekly meetings. And also there's a CSI implementation group that actually meets 3 times a week. So we can talk. I think we're out of time. All right, thank you. Thanks, everyone.
All right, that brings to an end this session. Thank you very much for all the lively conversation and very smart questions. And by the way, there's no such thing as a simple, dumb question. They're all good questions. Welcome you to join us tomorrow for the deep dive if you want to go into some more detail. And again, that we can treat as a reasonably interactive session. It seems like there's a lot of appetite for figuring stuff out in a collaborative forum. that's good news. I would also encourage you, even if you can't come to tomorrow's session, there are all the details. There is this white paper exists, it's been published. If you can't find it, you can email either of us or search on the internet, and we would really welcome your commentary on that. You can just add it to the document as comments in the sideline to say, why don't you talk about this thing, or you didn't talk about my thing, or whatever the comment might be. We really appreciate that. Thank you.